Hello class, this is Dr. Herat again. Today we're going to continue Laplace transforms and I'm going to look at how we can get inverse Laplace transforms given a function. So just to recap, remember that we said in class couple of days ago that if you are given a function ft, we can find its Laplace transform given by the notation capital F of a variable s, which is the Laplace transform of ft as is integral, right? So we worked some problems out and we figured out how to find Laplace transforms given a function. Now suppose you do the reverse. You are given the Laplace transformed function, capital F of s, and you need to figure out your ft, or the inverse Laplace transform. So the question is, how do you go about doing that? So to do that, let's do an example and see what we can do here. So you are given this Laplace transformed function in S space, so these in S. So we got to find out ft, right, which is the inverse Laplace transform of fs. So how do you do that? Well, if you do remember the table I showed you in class, which I'll show it to you again, this table, which is the more popular Laplace transform. So if you're given the left hand column is your function, the f of t, and the right hand side you get the Laplace transforms. So for example, if you have something like this as your Laplace transform function, capital F of s, then you know the inverse Laplace transform should be t, right? Same is true if you look at number 6. If you have 1 over s minus a as your capital F of s, right, or your Laplace transformed function, then your small f of t, your function, will be e to the at, right? So now let's go back and look at our problem. It is not anything like we see in our table, so we got to do something with it. And before I do anything, let me look at the denominator and check whether I can factor this out. Okay, so let's go and look at that. So let's look at f of s. Let me first of all push this a little up. Okay, so let's look at f of s is equal to s plus 19 s squared plus 3s minus 4. And if you try to factor it out, it actually does factor. It's going to be s minus 1 s plus 4. Okay, so now, well, still, if you look at the table, there is nothing that looks like it here. So if I go back again, remember we have these two, we have a function that we need to Laplace transform. But if you look at this and look at your table, there is nothing that looks like it here, except that if you look at this number 6, if I can factor that out, that statement out, then I may be able to find out what the Laplace transform is like. So if I can factor this statement out, right, then maybe I can find out the Laplace transform. So let's look at whether we can do that. So my question is, what can we do to factor this statement, which is s plus 19 divided by s minus 1 s plus 4. All right. Okay, can I find a and b such that they will be equal to each other? Left and right will be equal to each other. So I need to find a and b. Okay, so well, to do that, we can write this again. It will be s plus 19 over s minus 1 s plus 4 is equal to a. I am adding these two fractions. s minus 1. Right, so now we know that from this equation the numerators must be equal to each other, so now I can write numerators only, and the reason is that the denominators are the same on left and right, so I can equate the numerators, and I can expand this. Right hand side will be as plus 4a bs minus b. All right, so that's that. Now let's look at what we can do here. So I see that the s on the left hand side has a coefficient of 1 in front, so 1 is equal to, on the right hand side, right, the coefficient is a here and b here, right, so we will get a plus b. And if you look at the next one, there is 19 on the right hand side, so 19 is equal to, and the constants on the right hand side are 4a and minus b, 4a minus b. Right, so now from the top line I can say that b equals 1 minus a. If I plug that in to the second equation, I'll get 19 is equal to 4a minus 1 minus a. Right, so now if I clean that up a bit, I'll get 19 is equal 4a minus, oops, sorry, that'll be minus 1 plus a, and that will give me a is equal to 5, which would give me b is 1 minus 5 from the top equation here, and therefore b is going to be minus 4. Oh, wait, I think I made a mistake here. Sorry about that. A should be 4 here. There is 4a plus a is 5. This will go on that side, will be 20. So 20 divided by 5 is 4. And in that case, I got to change here too. This should be 4. And therefore b is minus 3. Sorry about that. Okay. So now I can write down my Fourier transformed function. F of s is equal to 4 divided by s minus 1 minus 3 divided by s plus 4. Okay, again, why is that? Well, if you go back, right, this is a over s minus 1 plus b over s plus 4, right? That's our function now. So now if I want to do the inverse Fourier transform of this function, right, so therefore our f of t is the inverse Fourier transform of f of s, which is going to be 4 times the inverse Fourier transform of 1 over s minus 1 minus 3 times the inverse Fourier transform of 1 over s plus 4. So now the question is, can I find the two patterns I see here and here on the right hand column in the table that's in your book? So let me go to that page. If you look at this, and if you look at the sixth row, you see that the right hand side has the same form we have, and if that's the case, the function ft, small ft, is going to be e to the at. Okay, so let's go and see what we have here. So remember what we just saw was that Inverse Fourier transform of 1 over s minus a is equal to e to the at, right? In that case, what do we get? So in the first one, we have a is equal to 1, right? So we will get f of t is 4 times e to the t, or 1t, minus 3 times. Now in this case, our a is going to be minus 4. Remember, we should have a minus there, but you have plus here. So we'll have e to the minus 4t. And there you go. That's the inverse Fourier transform of the function given to us. Right? So I hope this helps. Now I think you can do the last problem on your homework I gave on Wednesday. And hope this is okay. And I'll see you in class on Friday. All right. Thank you. Bye.